The first things, the two things on this quiz are graphing exponential functions and exponential growth and decay. These are the only two things on the quiz. So let's talk about them. First, exponential growth and decay. So graphing exponential functions, and the second thing is exponential growth and decay. And guys, this is going to be our last formalized assessment before the midterm. So this is our last formal assessment before the midterm. You obviously have the project that counts as a test grade, but after that project / party day, we are going to start our review process. So we're going to have a full 3 or 4 days of review. So that should be pretty good. Okay. So if you're looking to get your grade up, this is basically this and the project are your last times to really make an impact. So I really recommend you study for this quiz and do the best that you possibly can. So the first thing, graphing exponential functions. In order to start this process, we have to start with the general form of an exponential function that we've been working with, which is f of x equals a times b to the x. Now there are two things whenever we have a function that we should be able to immediately tell. First thing, the a tells us what of the graph? The y-intercept. The y-intercept of the graph is equal to a. And then the next thing is b, which tells us whether our function has exponential growth or exponential decay. And we might remember if b is in between 0 and 1, then we've got decay. And if b is greater than 1, then we've got growth. Okay, and if we remember, decay would look like this, and exponential growth would look like this. And the only thing to really remember here as well is that if a is negative, then this whole thing gets flipped. And if b is in between 0 and 1, it'll look like that. And if b is greater than 1, it'll look like this. Okay? So this is when a is greater than 0, and this is when a is less than 0. So this, I recommend you all have a piece of paper that has that on there. So just copy it down. This is being recorded. It's going to be on YouTube. If you don't want to take the time right now, fine. It'll be on YouTube. But I recommend you do. Why? Well, knowing this little bit of information here is going to help you out greatly, especially on this quiz, which is all going to be multiple choice. The way that the form of the questions is going to come out as, the form of the questions is going to be, here's a function, f of x equals 3 times 2 to the x or something. Match the graph. So find the graph that matches this function, so a, b, c, and d, right? Now, if you know these attributes, you can immediately eliminate some things. So let me give you an example here. let's say I tell you f of x equals 3 times 2 to the x. What do you immediately know about this? What does this 3 tell you? Yeah? The y-intercept is 3. This 3 doesn't tell you that there's growth. This is a. So what this tells us is the y-intercept is equal to 3. Now, if you're looking at 4 different pictures, 4 different graphs, and you already know that the y-intercept is 3, you can probably eliminate some, right? You can look at them and say, oh, this one's got a y-intercept of 2, this one's got a y-intercept of negative 3, this one's got a y-intercept of 4, whatever it is. But I can eliminate that because I know my y-intercept is at 3. Does that make sense? Don't look at these pictures necessarily right now. Okay, this is just, I'm telling you what decay and growth look like. Okay? And then the next thing you can know is from the 2. Is that greater than 1? So it's growth. It's exponential growth. So a is positive, so it's going to look like this. So if you see a graph that looks like this, you can immediately eliminate it. Or if it looks like that, or it looks like that, right? Because you know what the general shape, the general form of the graph is. Does that make sense to you guys? So just having this kind of memorized is really going to help you, especially on this quiz. With that being said, just one second. With that being said, on your midterm, there is going to be a whole graphing section where you're going to have to graph absolute value functions. You're going to have to graph quadratic functions. You have to graph exponential functions. You have to do it by hand. So this won't be the last time you'll be asked to graph exponential functions, but for now it's multiple choice. Yes? Questions? No? Question?
Yeah. What if the y is negative?
Good. Thank you. If the a is negative, thank you. That's a good question. So let me get back to this chart that I was showing you. Okay? If a is positive, then it's simple. Exponential decay, it's decaying. We see it. Exponential growth, it's growing, right? That's simple. But if a is negative, then the whole thing flips. But this is how you remember it, okay? Either way, if b is bigger than 1, so if this is 2 or 3 or 5 or 8 or something like that, then it's growing. If a is positive, like in this case, a is positive 3, then it grows more positive. If a is negative, like, and I'll give you an example of what this would look like. For instance, this could be a function negative 5 to the 4x. Well, it's exponential growth because b is bigger than 1, but a is negative, so it's growing more negative. You see this? A is positive, it grows more positive. A is negative, it grows more negative. Does that make sense to you guys? You can kind of understand that a little bit? An example of this one would be exactly like what we have, 3 times 2 to the x. What would exponential decay look like? Well, it could be like positive 4 times 1/2 to the x, because that's in between 0 and 1. Does that make sense to you guys? Okay, and this one would be like negative 2 times 1/3 to the x. Okay? So those are examples of what those forms would look like. Is that pretty clear?
What if it's like with something like with a decimal?
If it's a decimal, you have to question, is it between 0 and 1? Like instead of 1/3, this could have been 0.5 or 0.7 or something like that. Okay? And before we move on, you guys are definitely going to need calculators. So make sure you have a scientific calculator. If you don't have one at this point, go get one today. I know we haven't really been using calculators in this class, but you're definitely going to need it for this quiz.
You want to go now?
No, not right now. Okay. So is this pretty clear here? Why am I showing you this? I'm showing you this because it can help you. You can look at this and immediately see it's exponential growth. The y-intercept is 3, and it's positive, so it's got to look like this. You immediately can see it's got to look like this, so any other things you can eliminate. Does that make sense? Okay, let's practice this. Let's say I say this is A, this is B, this is C, and this is D. Okay? Let's give some examples. Actually, let's do it a little different. Let's call this graph 1, because I'm going to do, this will be fun. This will be fun. I got a fun idea. 1, 2, 3, and 4. Okay, so this one, 3 times 2 to the x, corresponds to this one here, graph number 2, right? You guys see that? It's positive and it's growth. So what I'm going to say is, which graph does this correspond to, 1 through 4? And everyone's going to raise their hand and you hold up a 2. Okay, so let's try it. So what graph does this correspond to? Go ahead. Nice. 2. Good. Okay, cool. Good. That works. All right, so let's do another one. So this one is 2. Okay. Now let's try this one. F of x equals negative 4 times 5 to the x. Which one does this correspond to? 1 through 4. 1 through 4. Okay. All right, take a look around. Well, let's see. It's negative, so I know it's going to be facing downwards. Okay. It's positive. It's positive. If it's negative, it's negative. Does that make sense? Okay. The only question is if it's growth or decay. Well, this is positive, more than 1, so it's growth. It's growing more negative, so it's going to look like number 4. Okay? That looks like number 4. Okay? Next. F of x equals 5 times 1/6 to the x. Which graph will this correspond to? 1 through 4. 1 through 4. Good. Well, it's positive, so I know my graph is on the positive side of the x-axis. And this is less than 1, so I know it's decay, so it's graph number 1. Okay. And the last one I'll do, f of x equals negative 7 times 0.3 to the x. Which one does this correspond to, 1 through 4? Come on, everyone. I want to see everyone's fingers. Yes. Good. Well, it's negative, so it's on the negative part of the x-axis. And it's less than 1, so it's decay. So it looks like that. Good. Yep, sure. Okay. Any questions on this? Any questions at all? Okay, so this will help you to eliminate a bunch of answer choices, and it can help you to get the right answer. It can also help you on the midterm to get partial credit. If you draw something and at least you get the form, it looks correct, maybe you got some points wrong, but at least you got the right shape, I'll give you partial credit. You see? So this will help you just to understand what you're kind of talking about. And what your graph should look like. But beyond that, you're going to actually have to graph it. Because chances are you won't be able to eliminate 3 out of the 4 choices. So you'll have to graph. So let's go ahead and do one. 3 times 2 to the x. So if I'm graphing this function, I have x, f of x. Use the same numbers I do all the time with exponentials. -2 through +2. And then I just go ahead and plug it in. If you have a calculator now, go ahead and pull it out. If you don't, that's fine. Yes, ma'am? Yeah, and you need to have a calculator for this quiz. Let's repeat that. You guys need to have a calculator. If you don't have a calculator, it's going to be almost impossible for you to pass this quiz. It'll be hard. Yes, ma'am. it has to be scientific. A scientific calculator. Scientific calculator. That's fine. Good. Yep. Cool. Good. Okay. Now, plug it in. 3 times 2 to the negative 2 is the same thing as 3 over 2 squared, which is 3 over 4. 3 times 2 to the negative 1 is the same as 3 over 2 to the 1, so 3 halves. 3 times 2 to the 0 is 3 times 1, which is 3. 3 times 2 to the 1 is 3 times 2, which is 6. And 3 times 2 squared is 3 times 4, which is 12. On the quiz, guys, I'm going to provide you with a coordinate plane. And you're not going to be graded on anything that you do on the coordinate plane, but say you make this table, but you want to graph it to actually get a visual, so you can graph it on the coordinate plane. I'll give you a blank coordinate plane that you can graph it on, and then when you graph it, you can then compare it to the answer choices to find the right answer choice. Does that make sense? So you're not going to have to draw your own coordinate plane. It'll be on there. Okay, you won't be graded on anything that you put on there, but it can help you if you so choose to use it. Okay, go ahead and plot your points. Negative 2, 3/4, that's here. Negative 1, 3/2 is here. 0, 3 is here. 1, 6 is here. And 2, 12 is here. And you've got your function. Okay. And you should, whenever you're graphing an exponential, make sure you include the exponent. That's super sloppy. The exponent is here at y equals 0. Any questions on that? No?
Like, I understand how to graph it, I just, like, that's the part where I just get lost, is, like, trying to keep up with the numbers, and it's really confusing.
I understand. You'll have a calculator, so if the exponents are confusing you, like, you can just use your calculator. But it's just practice. You gotta practice with it. The key here is you gotta remember that what you're plugging in for is the exponent, and then you just gotta go through the process. Yes, sir.
And what if, like, the second number is like a fraction, like 1/3, like 3 times?
I'm gonna do one like that right now. Okay. Any questions on how I did this? Okay. Now, what about if I had f of x equals 3 times 1/2 to the x? Well, I do the same thing. Okay. Starting with negative 2 is 3 times 1/2 to the negative 2. If you guys remember, we did this. If you guys remember when we were working with rational exponents, we worked with raising a fraction to a negative exponent. But whenever you put anything to a negative exponent, it just flips. So instead of 1/2, this becomes 3 times 2 squared, which is 2 squared is 4, so it's 3 times 4 is 12. And then if I raise it to the negative 1, it's the same thing as 3 times, instead of 1/2 to the negative 1, it's 2 to the positive 1, which is 3 times 2, which is 6. And then 3 times 1/2 to the 0 equals 3 times anything to the 0 is 1, so it's 3. And then 3 times 1/2 to the 1, well, that's just 3 over 2. It's 3 times 1/2. And then 3 times 1/2 squared equals, well, 1/2 squared. What's 1/2 squared? You can tell me. Someone. Anybody? 1/4. So it's 3 times 1/4 is 3 over 4. Okay. Once you have that, you go ahead and graph. -2, 12. -1, 6. 0, 3. 1, 3/2. And 2, 3/4. And there you go. Does that make sense? Yeah? Questions? Oops, any questions, guys? Any questions on this? You guys awake? You alive?
Somewhat.
What's infinity divided by infinity? What's infinity times infinity? I don't know.
A lot.
Infinity. What's the square root of infinity? What's infinity divided by 0?
1.
What's 0 divided by 0?
752. Dang.
That's a good guess, though. All right. So this is how you graph an exponential function. That's exponential decay. The previous one was exponential growth. Any questions on that? Okay. Good. You guys ever see Mr. T? You know who Mr. T is?
Yeah.
He's a big mohawk, right? He's a nice guy. Yeah. I never met him personally, but just feel it from him, you know. All right. Next is exponential growth and decay. All right. These are the equations, right? Exponential growth is a times 1 plus r to the t. That's exponential growth. And exponential decay is a times 1 minus r to the t. Okay? It seems like it's two equations, but really it's just one. It's just one equation, that's all. All right. And we know that A is your initial value. R is your rate. And T is your time. So in this kind of question, I would give you a question similar to your homework on lesson 10.3. It's just be a word problem. I would say something like someone buys a car for $45,000. It depreciates at a rate of 8% per year. Find out how much it will be worth at the end of 20 years. So you just have to realize that 45,000 is A, 8% is R, and 20 years is your T. So it's 45,000 times 1 plus, class, do I put 1 plus 8? What? 0.08. Okay, class poll. 1 finger in the air if pancakes are better, 2 fingers if waffles are better. Ready? 1 for pancakes, 2 for waffles. Go, go, go. Pancakes, waffles, waffles, pancakes. 1, neither? 1, so what? Pancakes, pancakes, waffles. Wow, we really, most people pancakes.
What about French toast?
French toast is 3. Okay, add 3 for French toast. Wow, you went deep. Nice. Cool.
That's not even in the same.
Have you guys ever had homemade Belgian waffles?
They're really good. I don't like Belgian.
All right. Okay, Belgian. You were just thinking like Eggo waffles. I get it. I get it. Okay. All right. So, so you plug in T is equal to 20. You plug in T is equal to 20 here. Okay, 45,000 times 1 plus 0.08 to the 20th power. Go ahead and do that in your calculators now, if you have them out. 1.08 to the 20, 209,743. Actually, the math department's kind of famous for making waffles. I don't know if you guys have known that. Yeah. And Mrs. Moeller makes some waffles too. I made some waffles last year.
Yeah,
I was cleaned it up for about an hour.
the day we have this class first, Bob, we should have a breakfast.
Yeah. Oh, that's something else we're going to do today. We have to plan for the party because obviously we want to all contribute. Okay, do you guys get this? You guys get this? No. Just kidding. Okay. All right. Shh. What did I do wrong? What did I do wrong? What did I do wrong? Someone tell me what I did wrong. I didn't do this on purpose. I just realized it.
Didn't you say it depreciates?
I said it depreciates. So what did I do wrong?
It's not
Yeah. No, not good. This is wrong. So it should have been 45,000 times 1 minus 0.08 to the 20. That'd be nice if you bought a car and it was worth $200,000 after 20 years. I guess some cars are like that, maybe. 1 minus 0.08, 8,491. That's a big difference. That's after 20. At 8% depreciation. Any questions on this? Okay, so we inadvertently saw exponential growth. We also saw exponential decay. Another thing that I could do is I could ask you something. I could ask you the same question, but say, give me the form of the function that would tell me how much the car is worth after t years. In this case, it would be 45,000 times 1 minus 0.08 to the t power. So I don't tell you how many years it is, but I'd ask you for the function. You'd have a list of functions, right? And you'd have to choose the right one. And you'd have to simplify. It would end up being 45,000 times 0.92 to the t. And so the correct answer would be that in this case, if I just ask you for the form of the function. Does that make sense? Any questions about this? Okay. So that's the end of our review session. Yeah? Yeah? All right. No questions. We're good. 10 questions, multiple choice. Do your homework. Helps classes today.